Hi guys, tonight we're exploring one of the most awe-inspiring and terrifying cosmic phenomena. What if the stars in our night sky suddenly started moving closer to Earth? Not gradually over billions of years, but perceptibly, measurably, changing the very sky above our heads. If you enjoy these stellar transformation sleep stories that reimagine the cosmos, hit that like button and subscribe for more. And drop a comment letting me know what time it is, where you are, and where you're listening from. It's great connecting with stargazers from every part of the world. Alright, let's begin. Imagine standing in your backyard on a clear summer night, gazing upward at the familiar constellation of Ursa Major, when something extraordinary catches your attention. The 7 bright stars that form the Big Dipper appear subtly different than they did just months ago. Dubhe and Merak, the pointer stars that have guided human navigation for millennia, seem fractionally closer together. Across the globe, amateur astronomers are frantically checking their equipment, convinced their telescopes are malfunctioning, while professional observatories scramble to verify an impossible observation that would fundamentally challenge everything we understand about the cosmos. The first confirmed measurements arrive from the Very Large Array in New Mexico, where radio telescopes spanning 27 kilometers detect minute but consistent changes in stellar parallax. Proxima Centauri, our nearest stellar neighbour at 4.24 light-years away, appears to have moved 3 billion kilometers closer to Earth in just 6 months. To put this in perspective, this represents movement at roughly 20,000 kilometers per second, approximately 7% the speed of light. Such velocities violate every known principle of stellar mechanics, yet the data is undeniable. Within 48 hours of the initial observations, the European Southern Observatory in Chile confirms similar movements across multiple stellar systems. Alpha Centauri A and B, the twin stars that make up the closest star system to our own Sun, have collectively shifted their position by nearly 2 billion kilometers. Barnard's star, a red dwarf located 6 light-years from Earth, shows movement at an even more dramatic rate of 30,000 kilometers per second. The implications ripple through the scientific community like a seismic shock wave. Dr. Elena Vasquez, director of the Atacama Large Millimeter Array, becomes one of the first scientists to grasp the full scope of what they are witnessing. As she studies parallax measurements from over 300 nearby stars, a terrifying pattern emerges. Every star within a 50 light-year radius of Earth is exhibiting coordinated movement toward our solar system. The velocities increase proportionally with distance, suggesting whatever force is causing this phenomenon operates on a scale that encompasses our entire local stellar neighborhood. The economic implications manifest almost immediately. Global stock markets, already volatile from increasing concerns about climate change and geopolitical tensions, experience the largest single-day decline in recorded history. The Dow Jones Industrial Average plummets 2,800 points as investors struggle to comprehend the potential consequences of fundamental physics appearing to break down. Gold prices surge to $4,700 per ounce as people desperately seek stable investments in a suddenly unstable universe. Meanwhile, governments worldwide convene emergency sessions. The United Nations Security Council holds its first closed-door meeting on astronomical phenomena, while NASA receives emergency funding authorization of $15 billion to accelerate deep space monitoring programs. The European Space Agency redirects its entire €6,400 million annual budget towards stellar observation, while China's National Space Administration mobilizes its network of radio telescopes across the country's 9.6 million square kilometer territory. Religious leaders grapple with theological implications that stretch back to humanity's earliest creation stories. The Vatican Observatory, one of the oldest astronomical research institutions in the world, issues carefully worded statements acknowledging the phenomena while emphasizing that divine providence operates through natural laws that humans may not yet fully comprehend. In contrast, evangelical churches across the American Bible Belt report attendance increases of up to 300% as congregations seek comfort in scriptural prophecies about signs in the heavens. As weeks pass, the movements become visible to amateur astronomers using modest equipment. Polaris, the North Star that has served as humanity's celestial anchor for over 5,000 years, begins drifting from its traditional position. Navigation systems that have relied on stellar positioning for centuries become increasingly unreliable. The International Maritime Organization issues global advisories to the world's 50,000 commercial vessels, recommending increased reliance on GPS systems while acknowledging that even satellite-based navigation depends ultimately on ground-based tracking stations that use star positions for calibration. The first major infrastructure failure occurs at the Atacama Desert Observatory in Chile, where $20 billion worth of precision equipment designed to track objects across cosmic distances becomes essentially useless as reference points shift daily. Similar problems plague observatories from Hawaii's Mauna Kea to South Africa's Sutherland Plateau. The Square Kilometre Array, humanity's most ambitious radio telescope project spanning 14 countries and representing an investment of €2 billion, faces the prospect of complete obsolescence before construction is even completed. Dr. Kenji Nakamura at the Tokyo Institute of Technology becomes the first scientist to propose a theoretical framework for what they are witnessing. His calculations suggest the stellar movements could only be explained by the presence of an object with mass equivalent to approximately 10 million solar masses moving through our local region of the galaxy. This hypothetical object would need to be invisible to all current detection methods while exerting gravitational influence across distances of dozens of light years. The implications of Dr. Nakamura's hypothesis send shockwaves through both scientific and popular culture communities. An object of such enormous mass moving, undetected through space, challenges fundamental assumptions about dark matter, black holes, and the nature of gravity itself. Conspiracy theories proliferate across social media platforms, with some claiming the phenomenon represents evidence of alien megastructures or interdimensional intrusions. Others propose that secret government experiments with exotic matter have somehow destabilized local space-time. Agricultural communities begin experiencing unexpected consequences as traditional planting and harvesting calendars, many based on stellar observations dating back thousands of years, become unreliable. The Dogon people of Mali, whose astronomical knowledge predates European discovery of Sirius B by centuries, report that their sacred star calendars no longer align with observed celestial movements. Similar disruptions affect indigenous communities from the Australian Aboriginal peoples, whose songlines encode star positions across 40,000 years of cultural memory, to the Inuit of northern Canada, whose hunting patterns follow stellar navigation techniques passed down through generations. Commercial aviation faces mounting challenges as pilots discover that celestial navigation techniques taught in flight schools no longer provide reliable backup to electronic systems. The International Civil Aviation Organization mandates emergency modifications to navigation protocols affecting the world's 26,000 commercial aircraft. Insurance companies begin calculating unprecedented risk assessments for space-based assets, with some estimates suggesting total claims could exceed $500 billion if stellar movements continue accelerating. By the 6-month mark, telescopic observations reveal that stellar movements are not uniform, but follow complex trajectories that suggest multiple gravitational influences. Wolf 359, a red dwarf located 7.9 light-years from Earth, appears to be accelerating at nearly 50,000 kilometers per second, while simultaneously exhibiting lateral movement that would carry it across 12 degrees of sky over the next decade. Sirius, the brightest star in our night sky, and located 8.6 light-years away, shows similar complex motion patterns that defy simple explanations. The space tourism industry, valued at approximately $400 billion annually, faces complete collapse as companies like SpaceX and Blue Origin confront the reality that their planned missions to establish permanent lunar and Martian colonies may need to account for dramatically altered stellar navigation environments. The Artemis program, NASA's ambitious plan to return humans to the Moon, with a budget of $28 billion, requires complete revision of mission parameters as traditional navigation references become unreliable. Underground communities of amateur radio operators and citizen scientists begin coordinating independent observation networks, sharing data across 6 continents through encrypted communications channels. These grassroots efforts, coordinating observations from over 12,000 individual stations, sometimes produce more detailed tracking data than official government programs. Their findings suggest that stellar movements exhibit subtle but consistent patterns that repeat on approximately 11-day cycles, hinting at some form of organized causation rather than random gravitational disruption. The first direct economic casualties emerge in industries dependent on precision timing and navigation. The global shipping industry, which moves 14 billion tons of cargo, annually worth over $14 trillion, begins experiencing systematic delays as traditional celestial navigation becomes unreliable. Container ships carrying everything from microchips manufactured in Taiwan to coffee beans grown in Ethiopia find themselves dependent entirely on satellite navigation systems that were originally designed as backup to stellar positioning methods. Religious pilgrimage sites around the world face unique challenges as traditional astronomical alignments change. The ancient city of Varanasi in India, where millions of Hindu pilgrims gather annually for ceremonies timed to specific stellar configurations, must adapt rituals that have remained unchanged for over 3,000 years. Similarly, the stone circles at Stonehenge, aligned to celestial events over 4,700 years ago, no longer accurately predict solstices and equinoxes as underlying stellar reference frames shift. Marine navigation, already challenged by climate change effects on traditional ocean currents, faces additional complications as stellar positioning becomes unreliable. The world's fishing fleets, representing an industry worth $240 billion annually and feeding over 3 billion people, must adapt to navigation methods that have guided ocean voyages since humanity first ventured beyond sight of land. Traditional Polynesian wayfinding techniques, which enabled navigation across millions of square kilometers of Pacific Ocean using only star positions and ocean swells, face obsolescence for the first time in over 2,000 years. Scientists at the Large Hadron Collider in Geneva redirect their 27-kilometer particle accelerator toward investigating whether the observed stellar movements might result from previously unknown fundamental forces. Their experiments, consuming enough electricity to power a city of 100,000 people, probe energy levels approaching those present during the universe's first moments. Early results suggest that conventional models of gravitation and spacetime may require fundamental revision to account for the observed phenomena. Military implications become increasingly apparent as defense systems worldwide depend on stellar navigation for everything from submarine positioning to intercontinental ballistic missile guidance. The United States Space Force, established in 2019 with an annual budget of $15 billion, faces the possibility that existing satellite networks and ground-based tracking systems may require complete reconstruction. Similar concerns plague the Russian Federation's military space program and China's rapidly expanding constellation of military satellites. the insurance industry confronts actuarial calculations unlike anything in its 300-year history. Lloyd's of London, which has insured everything from ships carrying tea from China in the 18th century to modern commercial satellites, struggles to assess risks when fundamental physical constants appear to be changing. Space insurance alone, covering assets worth over $400 billion in orbit, faces potential claims that could bankrupt entire sectors of the global economy. International cooperation reaches levels unprecedented since the Apollo program, as nations recognize that understanding this phenomenon requires resources beyond any single country's capabilities. The newly formed International Stellar Movement Observatory combines personnel and equipment from 37 countries, pooling resources worth over $60 billion in a desperate attempt to understand what is happening to our local corner of the universe. Theoretical physicists propose increasingly exotic explanations as conventional models fail to account for observed stellar movements. Some suggest that our solar system may be passing through a region of space where dark matter density is significantly higher than previously calculated, creating gravitational effects that operate on scales of dozens of light years. Others propose that we may be witnessing the influence of extra-dimensional objects that interact with our universe only through gravitational forces invisible to electromagnetic detection, but capable of moving stars across cosmic distances. The phenomenon begins affecting Earth's own orbit as the gravitational influences of moving stars create subtle but measurable perturbations. Deep space tracking stations detect minute changes in our planet's orbital velocity, shifts measured in fractions of millimeters per second that nonetheless represent enormous energies when scaled to a planet with a mass of nearly 6 trillion kilograms. Climate scientists scramble to model potential long-term effects on weather patterns, ocean currents, and seasonal cycles that have remained stable for millions of years. Agricultural regions dependent on precisely timed seasonal cycles face unprecedented challenges. California's Central Valley, which produces over 250 crops worth $47 billion annually, must adapt irrigation and planting schedules as traditional astronomical markers for seasonal changes become unreliable. Similar disruptions affect agricultural regions from Ukraine's grain-producing steppes to Argentina's cattle ranching pampas, potentially impacting food security for billions of people. The pharmaceutical industry discovers unexpected consequences as drug manufacturing processes that rely on precise timing, synchronized to astronomical events, begin experiencing quality control issues. Certain biological compounds, particularly those involved in circadian rhythm medications worth $12 billion annually, show altered effectiveness as the stellar reference frames used in manufacturing protocols shift unpredictably. Cultural institutions worldwide grapple with the implications of changing star positions on humanity's oldest art forms and traditions. The Metropolitan Museum of Art in New York begins reassessing ancient astronomical artifacts whose interpretations depend on star positions that may no longer be accurate. Cave paintings in Lascaux, France, which include sophisticated star maps created 17,000 years ago, suddenly require reinterpretation as the celestial references they depict no longer match observable star positions. Emergency protocols developed for asteroid impacts and solar flares prove inadequate for a phenomenon that affects the fundamental structure of local space-time. The United Nations Office for Outer Space Affairs, typically concerned with satellite registration and space debris tracking, finds itself coordinating humanity's response to a crisis that transcends all existing frameworks for space-related emergencies. Remote sensing satellites designed to monitor Earth's environment from orbit begin experiencing navigation difficulties as star tracker systems lose their celestial reference points. Weather forecasting, which depends on precise satellite positioning to within meters of accuracy, faces degradation that could affect everything from agricultural planning to airline routing decisions, impacting millions of flights annually. The search for extraterrestrial intelligence takes on new urgency as scientists consider whether the stellar movements might represent evidence of large-scale engineering by advanced civilizations. Radio telescopes previously dedicated to detecting signals from distant planets refocus on monitoring our local stellar neighborhood for any artificial patterns in the observed movements. The possibility that we might be witnessing megastructure construction or stellar engineering by entities capable of moving entire star systems becomes a serious topic of scientific investigation rather than science fiction speculation. Ocean tide patterns influenced by complex gravitational interactions between Earth, Moon, and distant stars begin exhibiting subtle anomalies that affect coastal communities worldwide. Fishing villages in Bangladesh that have depended on predictable tidal cycles for over 1,000 years face disruptions that threaten traditional fishing methods. Similar effects impact coastal ecosystems from the Wadden Sea in northern Europe to the Great Barrier Reef in Australia, as marine species that evolve to synchronize breeding cycles with astronomical events find their environmental cues disrupted. The Global Positioning System, comprising 31 satellites providing navigation services to over 4 billion users worldwide, requires continuous recalibration as ground-based tracking stations lose their stellar reference points. Precision agriculture, which depends on GPS accuracy measured in centimeters to optimize planting patterns across millions of hectares of farmland, faces degradation that could reduce crop yields and increase food costs for populations already struggling with inflation and supply chain disruptions. Financial markets experience volatility unlike anything since the Great Depression, as investors struggle to price risks that extend beyond terrestrial concerns to the fundamental stability of physical reality itself. The derivatives market, worth over $600 trillion in notional value, faces the challenge of hedging against risks that conventional economic models never contemplated. Some investment funds begin incorporating astronomical risk assessment into their portfolios for the first time in financial history. Archaeological sites aligned to astronomical phenomena require reinterpretation as the stellar positions they reference shift beyond recognition. Chichen Itza in Mexico, where the ancient Maya constructed pyramids aligned to track Venus, and other celestial objects across centuries of observations, faces the prospect that thousands of years of accumulated astronomical knowledge may no longer accurately predict celestial events. Similar challenges affect sites from Angkor Wat in Cambodia to the medicine wheels of Native American communities across the North American plains. Communication satellites in geostationary orbit find their positioning systems compromised as the stellar references used for station keeping become unreliable. The global telecommunications industry, worth over $1.6 trillion annually, faces the possibility of widespread service disruptions as satellite operators struggle to maintain precise orbital positions without reliable celestial navigation references. Mountain observatories that have operated for over a century discover that their precisely calibrated instruments, some worth hundreds of millions of dollars, require complete recalibration as the stellar reference frames they were designed to track shift beyond their operational parameters. The Palomar Observatory in California, which has contributed to astronomical discoveries since 1948, faces the possibility that its 5-meter Hale telescope may require fundamental modifications to continue functioning effectively. Indigenous communities whose traditional ecological knowledge depends on astronomical observations for everything from predicting animal migration patterns to timing traditional ceremonies find themselves custodians of wisdom that may no longer apply to observable reality. The Lakota people of the Great Plains, whose buffalo hunting traditions were timed to star positions observed for centuries, must adapt practices that connect them to their ancestors while acknowledging that the celestial foundations of their culture are literally moving through space. The phenomenon accelerates as approaching stars begin exhibiting gravitational effects measurable by sensitive instruments on Earth. Laser interferometry experiments designed to detect gravitational waves from distant cosmic events begin registering continuous background signals as the changing distribution of nearby stellar masses creates ripples in local space-time geometry. These measurements suggest that our solar system may be approaching a gravitational environment unlike anything it has experienced in billions of years of galactic evolution. Commercial spaceflight companies face the reality that their business models, based on precisely calculated orbital mechanics and navigation to specific destinations like the International Space Station, may require complete revision. SpaceX's Falcon Heavy rockets, capable of delivering 63 tons to low Earth orbit at a cost of $90 million per launch, must account for changing gravitational fields that affect everything from fuel consumption calculations to rendezvous timing with orbiting platforms. Deep space missions already in progress confront navigation challenges that their original mission planners never anticipated. The James Webb Space Telescope, positioned at the Earth-Sun L2, Lagrange point 1.5 million kilometers from Earth, requires continuous course corrections as the gravitational influences of moving stars alter the delicate balance of forces that maintain its orbital position. Similar challenges affect probes throughout the solar system, from Mars rovers to outer planet orbiters, whose mission success depends on precise navigation calculations based on stable stellar reference frames. The mystery deepens as detailed observations reveal that stellar movements are not random, but follow complex patterns suggesting coordination across distances that light would take decades to traverse. Wolf 1061, located 13.8 light-years from Earth, appears to be moving in coordination with Ross 128, located 11 light-years away, despite the fact that light signals between these systems would require over 25 years to complete a round-trip journey. Such coordination challenges fundamental assumptions about causality and information transfer across cosmic distances. Religious communities worldwide grapple with theological implications that stretch beyond traditional eschatological frameworks. The Catholic Church convenes special theological commissions to examine whether the stellar movements represent divine intervention in natural processes or evidence that creation itself operates according to principles beyond current human understanding. Protestant denominations debate whether the phenomena fulfill biblical prophecies about signs in the heavens, while Islamic scholars examine the movements in light of Quranic verses describing the precise order of celestial mechanics. The search for patterns in the stellar movements reveals correlations with ancient calendar systems that predate modern astronomy by thousands of years. The Mayan long count calendar, which tracks cosmic cycles extending over 26,000 years, appears to contain mathematical relationships that correspond to the observed stellar movement patterns with uncanny accuracy. Similar correlations emerge from ancient Vedic texts describing cosmic cycles and stellar positions that were compiled over 3,000 years ago. Global supply chains face disruptions as traditional navigation methods become unreliable for the cargo ships that transport 90% of international trade by volume. Container vessels carrying goods worth over $11 trillion annually between the world's major ports must rely entirely on satellite navigation systems that were originally designed as backup to stellar positioning methods. Port authorities from Rotterdam to Shanghai implement emergency protocols for guiding ships whose navigation systems may fail without warning. The implications for human space exploration extend far beyond current missions to encompass humanity's long-term survival as a spacefaring species. Plans for interstellar travel, previously considered ventures for the distant future, suddenly become urgent necessities as scientists realize that our local stellar environment may be fundamentally unstable. Generation ships designed to travel for centuries between star systems would need to account for target destinations that might move significantly during the journey duration. As stellar movements continue accelerating, the night sky visible from Earth begins changing rapidly enough for casual observers to notice differences from month to month. Amateur astronomy clubs worldwide report membership increases of over 400%, as people seek to understand the transformation occurring above their heads. Planetariums struggle to update their star shows as the traditional constellations that have guided human navigation and storytelling for millennia gradually shift beyond recognition. The phenomenon forces humanity to confront fundamental questions about our place in the universe and the nature of reality itself. If stars can move in coordinated patterns across dozens of light years apparently instantaneously, then either our understanding of physics is fundamentally incomplete, or we are witnessing evidence of intelligence and engineering capabilities that operate on scales beyond anything previously imagined. The distinction between natural phenomena and artificial manipulation becomes meaningless when confronted with events that transcend both our scientific models and our conceptual frameworks for understanding cosmic processes. In observatories and laboratories around the world, scientists work frantically to understand what may be the most significant discovery in human history. The approaching stars carry with them not just gravitational influences and navigation challenges, but fundamental questions about the nature of consciousness, intelligence, and purpose in a universe that may be far stranger and more intentionally designed than we ever dared imagine. As the stellar movements continue, humanity stands at the threshold of discoveries that will either expand our understanding of reality beyond all previous boundaries, or force us to accept that we are participants in cosmic processes whose scope and purpose remain utterly beyond our current comprehension.